Here's some important points about using induction, and you're going to start seeing these now in steps that frankly I show you here as well, so that's the good news. Is mathematically, you actually should really understand now what this all means. You know for all values of k, p of k implies that p of k plus 1 is going to imply that for all n, it ends at n. This should now make sense from what we've done in this class to basically tell you, hey, if it works for one and it works for the next one above that, it's probably going to work for all the way up to n. And that's the overall rule of inference that we're going to use. Hey, heard that before? That's the interesting part about all of this. So you're actually going to see, so let me actually go down here, you're actually going to see me translate the equation that's given into our P notation when it comes to this because, hey, it is a proposition. We are checking it out. We're not sure yet. That's why we're doing the proof. We are going to do a base case, so that's part of the mathematical induction, is why we do a base case is so we don't assume that P of K or P of N in this case works. We're going to try the base case first, see if it works out, and then we'll continue with the rest of our proof. So by the way, if the base case doesn't work, then don't bother with the proof. We have to at least start with the base case, which, by the way, doesn't always start at 1. So be very, very careful about that. You can assume that, like in this problem right here, you don't see anything. They usually start at the integer 1. They will specify, or the question will specify if it needs to start somewhere else. So just a heads up on that as well. But that's our important parts, or parts and points about our inductions that we're about to do.